Okay, folks, we are still on section 4-4. However, we are now in the second recording. I can only do 15 minutes at a time, so I have to break these up a little bit. All right, so we just talked about the fundamental rule. Now we're going to get into the other two rules. One of the rules deals with permutations, and the other one deals with combinations. And it turns out that there are two separate rules when it comes to permutations. Now, in order for us to get started on this, we have to learn a new thing, a new notation, and that's called the so-called factorial notation. The factorial notation basically looks like this. 5 factorial means 5 times 4 times 3 times 2 times 1. 9 factorial, 9 times 8 times 7 times 6 times 5. You just multiply it out, okay? There's a special rule for 0. 0 factorial, and he's got some stuff missing here, unfortunately. It should be 0 factorial equals 1. So that's just a problem with the electronic book. I just looked in the textbook and the printed book, and everything is okay. He does have the 0 factorial equals 1 there. All right, so in general, this is how it works. For any counting number n factorial is n times n minus 1, in other words, 1 less, times n minus 2, in other words, 1 less than that, all the way down to 1. So that's exactly what we have here. It's if we're talking 5 factorial is 5 times 1 less than 5 times 1 less than 4 times 1 less than 3. You see what's going on? We just keep on reducing it by 1. Okay? So hopefully you've seen this before in Math 35. Okay, so now we're going to talk about what is a permutation. A permutation is an arrangement of n objects in a specific order. So the clues, what you look for is this word right here, arrangement. It has to be an arrangement, is where you're putting it in a particular order. So what we'll see here in a little bit is there's a distinction between a permutation and a combination, and we'll see that here in just a second. But the key, I would say, is this business right here. We're talking about it's in a specific order or not. Okay, so we always love examples. So let's take a look at this example here. This is a so-called lock codes. So it could be a combination lock that has 4 positions. It could be your personal ID number for anything that you're dealing with, the bank or what have you. Okay. All right. And in this scenario, this example we're dealing with here, we're talking about, we're only going to pick 4 different digits, 0, 1, 2, 3. How many different combinations can be made? There's no replacement here. Okay, what we have decided here is that they're going to be 4 different digits. So I can't have, for example, 1, 1, 1, 1, 1. I can't do 1, 2, 2, 3. I can't do that. I have to use 4 different digits of the first 4 digits. So there's no replacement. How many different combinations can be made? So unfortunately, there's a little typo here. This should be, see, this equal sign here should be down here. It should be 4 factorial equals 4 times 3 times 2 times 1. So let's see if we can figure this out. In your mind, put an equal sign right there, right where I'm at there. So you have 4 choices for the first digit, right? You have 0, 1, 2, 3. Pick whichever one you want, but you have 4 choices. Well, after you pick one, you don't have 4 choices anymore. You only have 3 choices. Then after you pick that guy, you don't have 3 choices anymore. You only have 2 choices, and so forth, okay? So that's why we multiply 4 times 3 times 2 times 1, which if you do the arithmetic, that comes out to be 24. Okay, so we're using all 4 of the digits. So that's what he says right here. Example 442, all the digits or all the objects were used up. But what happens if not all of the objects are used up? Well, we're going to talk about that here in 443. So the business owner wants to rank the top 3 locations selected from his 5 locations. So he's not going to use up all 5 of the locations. He's only going to use up the 3 locations. He's going to pick the top 3 locations. He's at 5 locations for a business. You know, he has Riverside, he has Corona, he has Rialto, he has San Bernardino, he has Redlands, whatever they happen to be. Well, once he picks one, he can't use it again, right? You can't have Riverside be as your first choice and as your second choice. That wouldn't make any sense. So you're using up. There's no replacement of the locations. But you're not using all 5 of them. You're only picking 3 of them. You're choosing 3 out of the 5. So the fundamental counting rule is the same rule we used before. You can select any one of the 5 for first choice, then any one of the remaining 4, and then any one of the remaining 3 choices. Did I say that right? Let's see if I got it right here. Any one of the 5 for the first choice. Then how many do you have left? You have 4. So that any of the 4 can go into the second choice. And then we have, we've already used 2 of them. So we only have 3 left over for that third choice. Okay, so you can see how that goes, right? So 5 times 4 times 3 is 60. So there's 60 different ways that she could rank them. These are called permutations. The reason they're called permutations is because the order counts. That's the key rule right here, where it says a permutation is an arrangement of n objects in a specific order. The order counts. We care about the order. In a minute, we're going to talk about combinations. We don't care about the order in a combination. So here's the first rule. The arrangement of n objects in a specific order using r objects at a time is called a permutation. It's n objects taking r objects at a time. So we usually say it's n choose r permutations. Here's the formula for it, okay? So it's n factorial over n minus r factorial. That looks horrible, but I swear to you, it's not as bad as it looks. So this n choose r permutations, what does that mean? It means, for example, 6 choose 4 is 6 factorial on top, 6 subtract 4 factorial on the bottom. Well, what's 6 minus 4 factorial? That's 2 factorial. So I could write it as 6 factorial over 2 factorial. So now what do I got? I got on top 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And on the bottom I have 2 factorial. That's 2 times 1. So if you do all the arithmetic, what you come up with is 360. So what I want to point out to you here is that it's always going to be the case. The bottom here is n subtract r factorial. Do 3 or 4 or 5 or 20, however many it takes for you to see this. But the bottom line here is that what's really going on is that you have the top, you have the first r of the guys are going to survive. Everybody else gets canceled out. So in this particular case, 6 subtract 4, their first 4 are going to survive. 6 times 5 times 4 times 3. Those guys survive. The rest of them get canceled out. That's just the way it always works out. And you can do a dozen examples and you'll see what I'm talking about. Or not. If you don't want to remember that little rule, just go ahead and write everything out. But I'm just telling you, it's a lot easier if you just can remember that one little rule. The first R of the guys on top survive. Everybody else gets canceled out. Okay? All right. So now we solved this example 4-42 and we solved 4-43. We solved that using the fundamental multiplication rule, but now let's see if we can solve it using the permutation rule. Okay, so in the first one it was, oh, you know what, this is where he kind of screws up here too. Okay, in 442, he says right here, in example 4-42, 5 locations were taken and then arranged in order, blah, blah, blah. Well, unfortunately, that's not true. Example 4-42, that was the example here of the lock codes. I believe what happened, I looked it up one time, in the previous edition, the examples were different. Okay, so don't blow your mind on this. It's not any big deal. It's just a typographical error, publisher error. So let's forget about example 442. So forget about 442. Let's look at 443. We had 3 locations were selected from 5 locations. So it's 5, choose 3. That's the way you should say it. 5 locations, I choose 3 of them. So 5 factorials on top, that's 5, 4, 3, 2, 1. 5 take away 3 factorials on the bottom. So 5 take away 3 is 2 factorial. That's on the bottom. And look what happens. They cancel. So you can do it that way. That's kind of the long way of doing it. Or you can just make this observation that I shared with you. And you say, well, listen, the R, whatever the R is here, that's how many of these top guys are going to survive. So if it's 5, choose 3, only 3 of these top guys are going to survive. 5, 4, and 3. 3 of them survive, okay? All right, so hopefully that helps you there. Let's take another example here. Example 4-44. You got a radio show host, and he can select 3 of 6 special guests for the program, okay? The order of appearance is important. So that's telling you that it's a permutation. So that tells me that I need to use the permutation rule here. N choose R permutation. So here's my formula. So it's going to be N is 6. There's 6 guests total. I'm choosing 3 of them. So how many ways can I do it? The order is important. So it's permutation. So it's 6 choose 3. So 6 factorial on the top, 6 subtract 3 on the bottom. Work it all out. It gives you 120. So now here's some more notation that he has. He's showing you here. It's 6, 5, 4, and then 3 factorial. Do you see why that's true? Because 6 times 5 times 4 times 3 times 2 times 1. 3 times 2 times 1 is the same as 3 factorial. I got 3 factorial on the bottom. These guys cancel. My shortcut way is just to say, hey, listen, R is, this R is 3, so only on the top, only the first 3 guys are going to survive. Everybody else gets canceled out. Okay. Same idea here. We've got a musical play. We have 9 plays to present. We're going to pick 2 of them. So it's 9 factorial on the top. Only the first 2 guys are going to survive. That's 9 times. These guys can cancel here. 9 times 8 is 72. Okay, so there's 72 possibilities. All right. So here's the key thing. In these previous examples, all of the items involved, permutations, were different. But sometimes you can have the items are identical. So let me talk about that in the next video. I'm running out of time. So we have a second rule we're going to talk about in just one second. But everything here, all of the items are exactly the same. They're whatever they happen to be. They're plays, they're locations, or whatever, okay? But sometimes that's not true. Sometimes we don't have all of the items being identical. But what we've talked about so far, everybody's the same. It's a play, it's a location, it's a guest. They're all the same. The next rule is going to be slightly different. So I'll talk about that in the next video. So this is the end of this video.